So just to give you a little bit of background, the engineers that built ThoughtSpot, our co-founders, came from consumer search technologies, which is very different from most BI tools. So they actually came over from Google, Amazon, Microsoft, Bing, and LinkedIn. And the difference that I'll show you in a second between having consumer search engineers versus BI engineers is their standards in terms of how fast users should get their hands and answers on data is much, much different from enterprise expectations. So in the consumer world, when we want to get answers from petabytes of data, we go to Yelp, Yahoo, Google, Orbitz, any one of those is search-based. So what they wanted to do is actually bring those standards in terms of how fast we should get answers to the enterprise and to petabytes or terabytes of information and data that's in the enterprise. The technology that they built that comes together to form ThoughtSpot are actually 5 different technologies. Right now, we're looking at the UI, which is HTML5 based, so you can have hundreds or thousands of users log in at the same time and use ThoughtSpot from a web browser, from their phone, from laptop, whatever. The technologies that are underneath include a in-memory columnar database, which they built from scratch because they couldn't find a database that was fast enough, so they actually built their own. On top of that, they built an in-memory data cache, so we cache terabytes of data in memory within ThoughtSpot. On top of that, they built an in-memory cluster distribution. And on top of that, they actually built a new breed of search engine that's actually more complex to code for than Google, which is essentially a search engine for numbers. So I'll show you in a second when I do my search that what the search engine does is it runs SQL in the background, it crunches numbers on the fly, and it brings an answer back to the user within 200 milliseconds, which is the same speed as Google. What the user is going to be greeted by when they log in is an example of a dashboard. It's actually what we call a pinboard. And the difference here is that the data that you see in these answers, which I believe Tableau calls cards, is actually updated in real time. So as you cache data from your data sources, whether that's medical records, billions of them, or CRM, or Hadoop, or Oracle, Microsoft SQL, a random Excel file that you want uploaded, we can actually cross-query it all the time. And as new data comes in, it's actually reflected in these visualizations. So they're never static or stagnant. They're always live. So up at the top, this is really where we stand out. So the search bar means that your user can type in a search against petabytes of data and get their answer. So from a payments perspective and claims data, I might want to look at, say, payment amount by date. So let's just type that in. Let's do that last year. And let's look at that by age group, and then maybe also by gender. Visualization changes as I change my request. So simply if I delete gender, you actually see the visualization update on the fly as well. So it will update to only be the payment amount by payment date last year by age group. It's doing a couple things when I search. One, it will pick the most relevant visualization based on the question that I asked. So in this case, it chose a line chart as opposed to a bar chart. We have about 25 to 30 different visualizations that we can use. So it will pick the one that's most relevant, but then as a user, you can go in and edit it so that you get what you want. Like this might be prettier in my point of view. From here, if I go back up to the search, as a user searches, it actually makes suggestions to the user on the fly. So it does that in a couple different ways. The first one is that it will find data that would make sense with what you've typed in. So the next suggestion is gender. The next suggestion, 2 down, is number of payments. And what it's actually looking at is, one, only what makes sense. So it's not going to suggest something that would give a user a wrong answer. The other thing is it will actually only make suggestions to me based on the user. So it knows who I am when I type in a search, and it makes suggestions to me based on the metrics and the attributes that I as a user use commonly. After that, it prioritizes attributes and measurements that my company uses a lot. And those will just be down in the list below my things. It's very similar to the way that Google works. Google has usage-based ranking as well. So you know that when you start to type something in Google and it makes suggestions to you to finish your sentence. It's the same thing here. Jakafi is one of our bigger payment drugs for the male group. And over here, it's the same for females. If you're talking about just seeing the data view, you can click on data view so that you can just see the raw data. and that'll give me the exact numbers. So I can actually see the total payment amount for each one of these. You can also drill down further, so I can look into that by state as well. So now we're drilling down into the procedures. So I'll drill down into this and look at it by state, and it will actually update the query that I did and then all of the numbers on the fly for me as well. So now we're looking at payment amounts just on Jakafi across the state. And if I go back to that visualization, it's actually going to show that to me in the visualization form. However, it looks like, so now it's just giving you a number, and we can do it by date, and that will give it a prettier visualization probably. So the way that this works is it's actually schema agnostic. We essentially cache all of your memory in data within ThoughtSpot. It doesn't matter how that data is really structured, so long as there's some structure to it. And the reason for that requirement is when you start to search keywords that are saved in perhaps a Word doc or an email, there's no relationship between that data. So if it finds, say, the word Jakafi in an email and it relates it to sales by date, you would get a wrong answer. So that's why we really only do semi-structured, which would apply to Hadoop, or structured data, so relational data set. What we found in healthcare is that most of the time that data is stored in some sort of relational manner. So you can see patient name, date, ER visit date, and then maybe drugs. And we can search within text fields. So if you also say, in this use case, you wanted to use this for patient satisfaction levels, and you've sent out surveys to patients to find out how they feel about the treatment that they received in the ER, we can still search within the text field under their comments for their ER visit. So just in case, something that like BI teams and IT teams often ask us about is, how do we know that this is right? How do we know what it's doing behind the scenes? If you go over here and you click on this question mark, you can actually see what the search engine is doing for you on the fly. So from here, you can see that it computed total payment amount. It did that for each payment date. It filtered on the covered drug known as Jakafi. It did that for just males. Then it sorted by payment date. And then it linked information from only about 2 tables in this case. Most of our clients use us with about 18 different data sources. So in the case of Charles Schwab, which is one of our customers, they use us with 20 different data sources. In terms of pharma, we've been adopted by Amgen. The way that they're using us today is to identify successful or not successful patient cohorts for particular drugs. So occasionally prior to FDA approval, they're tracking drug success. Another healthcare case, we've been adopted by St. Jude's. They're actually using us more to follow or donations. They wanted to track how their different fundraising campaigns were helping them. So they would do, something like a gold platter event, and they would people that pay $2,000 per plate. But after that, they wouldn't be able to track what happens to those donors afterwards. Do they continue to donate in the future? How can we better track them, hold on to them, things like that. We work with anything, your CRM, your cloud, Hadoop, Oracle, Microsoft, Excel, CSV, definitely any medical systems you have, POS systems when someone runs their card to pay for their treatment. As long as there's some sort of like column, cell, row, we're fine. Traditional BI tools take a couple months to actually deploy and be up and running for you because they have to figure out your schema. They have to figure out which data you want to pull from. Deployment with ThoughtSpot is actually on average between 3 days to 2 weeks. So it's very, very fast. We can actually be up and running in 4 hours. And that was the case with Walmart, which uses us for about 10 to 12 terabytes of data. That's the case for Charles Schwab. That's the case for Amgen. That's the case for TrackPhone. They were all up and running in a couple hours and fully deployed with their teams in 2 weeks. It's very fast. The way that it is so fast is that we're an on-prem solution, which is usually something that our regulatory companies like because we sit behind their firewall and they don't or they are not able to send data off-site, such as to the cloud. The way that it works is we actually work with you to figure out what the most valuable use case for ThoughtSpot within your company would be, whether that would be identifying the patients that are highest risk for certain diseases or another use case. We figure out what data we need to cache in memory within ThoughtSpot to make your search possible. We cache that data in memory within ThoughtSpot, and then we essentially create new column headers, or you can say aliases, for those columns. I'm sure in your environment, you wouldn't have a column that's called payment date. It might be called date _ XDX _ PY ments _ 2013 or something like that. So what we do is we actually create a very simple column header just within ThoughtSpot's instance that enables this simple search for the user. So they can simply type in payment date. The power is the instant search, so getting fast answers. You might use tools today for reporting or dashboards, so you can certainly do that here as well. I can actually create a pin board or a dashboard like you saw when we first logged in on the fly, so you can actually create it just as fast as you can do any search, and I can share this immediately. From here, I can actually create a new pin board, so I'm just going to do that here. And we've just added this visualization to the pin board. I can continue to work on this and do it by age group as well. And now we secure data down to not only the object and column, which is pretty traditional with BI tools, but also down to the row. So if you don't want certain groups being able to see patient IDs, for example, or you don't want them to be able to see one row of data, you can actually control that. We connect to LDAP and Active Directory so that IT can typically assign who has what rights to view what data. In that case, if they asked a question that involved data that they shouldn't see, typically what would happen is they simply won't see maybe the line of data for males 65 to 74. As you can see in my screen, if they weren't allowed to see that data, they simply wouldn't see this green line in the chart. So they can still ask those questions. They're just not going to have access to that answer in the visualization. If your CEO logs in, sees my pin board that I've just added here, he can actually go in, click on that little edit symbol, and start to go into the exact query that I asked. So it's actually recalculating this on the fly. So it's not, like I said, it's not a static report. It's always up to date. So it's recalculating that right now. My CEO can go in and actually go into the original query I asked and start to get an answer that he wants, if he wants to get more specific. So there's no waiting on IT to build reports anymore. They can do it from here. They can also drill down into any dimension of the data that's available and get the answer that they want. So a common example I use is if you were to look, say in the retail sense, want to look at sales by region, which I guess you could do in the medical sense as well. So if you were to type that in and you as a user only had access to see West data, but you weren't allowed to see East data, it would still provide you with a visualization, but it wouldn't show that visualization containing West data. So you would only get a graph for the East. If you want to change the visualization type, it will give you the options here. It will gray out those options that would not make sense for the question that you've asked. So it protects the user, again, from making kind of a stupid move. So from here, I can see those visualizations that do make sense based on the question that I asked. And so we do have about 25 to 30 here. We can do pretty much any level calculus, college calculus, we typically say. So you can do growth, average, standard deviation, anything like that. It'll calculate that for you on the fly. So here we entered in growth and it calculated that for me. I didn't have to know what type of SQL code I needed to know in order to calculate growth, which can oftentimes be a pretty complex. What their goal was initially with this tool was to really focus on perfecting a new type of search that hasn't existed yet. What came next was being able to keep up with all the other tools and even maybe go ahead of them in terms of visualizations. And then from there, we're actually working on going farther. So visualizations and then that search were really some of the first things that we wanted to do. And now we're kind of moving forward into things like voice control, apps, of course, cloud. We're saying that we're available and we will become available as soon as the first customer absolutely has to have cloud. The process is figuring out what is going to be the highest value data for you or the data that's immediately going to provide the highest ROI for you. So sometimes that can be, tracking patient outcomes, tracking patient satisfaction so that your hospital gets better reviews. Depends on really what your medical center would be most concerned with. From there, we work backwards. So we figure out, okay, this is the data that's the highest value. So now we could figure out which data you'd want to cache in ThoughtSpot. And from there, we figure out what are the types of questions you want to answer, and we prove to you that we can answer all of those questions. And we essentially do a proof of concept, which is to prove to you and your team that we can do it and we can be up and running in 2 weeks. And from there, there's essentially an agreement with that proof of concept that if we prove ourselves, that you would then purchase ThoughtSpot.